Before a mineral deposit is discovered, before a geological model is built, and before a mine begins, someone must walk the land, someone must observe the rocks, and someone must read the Earth's history. That person is a field geologist, and the language of that work is geological mapping. Part 1. What's geological mapping? Geological mapping is the process of observing, describing, and recording geological features in the field. A geologist studies rock types, mineral composition, structures, and relationships between rock units. The final product is a geological map, which is a scientific interpretation of the Earth's surface. Part 2. The language of the outcrop. The outcrop is the geologist's classroom. Every outcrop contains valuable information. Key vocabulary: outcrop, lithology, texture, color, grain size, and weathering. Example sentences: this outcrop consists of fine-grained basalt. The granite is highly weathered. The rock shows a porphyritic texture. Good geologists do not just look at rocks, they describe them precisely. Part 3. Geological contacts and relationships. One of the most important questions in the field is how do different rock units relate to each other. Key vocabulary: contact, conformable contact, and conformity, intrusive contact, and fault contact. Examples: the granite has an intrusive contact with the surrounding volcanic rocks. This unconformity represents a gap in geological time. Understanding contacts helps geologists reconstruct Earth's history. Part 4. Measuring geological structures. A geologist must not only describe rocks, but also measure their orientation. Key vocabulary: strike, dip, dip direction, bedding, foliation, and lineament. For example, the bedding strikes northeast and dips 40 degrees southeast. The schist displays a strong foliation. These measurements allow geologists to visualize structures beneath the surface. Part 5. From field notes to geological mapping. Every observation has a purpose: a note in a field, a GPS point, a rock description, and a structural measurement all become part of a large picture, which is a geological map that transforms thousands of observations into a story of Earth's evolution. A professional geologist might say the area is dominated by metavolcanic rocks, intruded by granitic bodies. The contacts are locally sheared, and the rocks exhibit strong hydrothermal alteration along northeast trending structures. This is the language of professional geological interpretation. A geologist doesn't simply walk across the landscape. A geologist reads it. Every outcrop is a page, every structure is a sentence, and every geological map is a story written over millions of years. Learn the language of geological mapping, and you learn to read the earth itself. I will see you in the next lesson.